These are notes for Melham's Math 60, Thursday, April the 16th, section 8.4, page 725. We are graphing quadratic equations. They're going to be something called parabolas. The parabolas will either open up or down, be U-shape or upside down U-shape. We'll have something called the vertex form of a parabola. That means it looks like this. F of x is equal to a times x minus h squared plus k, some constant. If you have the equation of this form, then the vertex we abbreviate with v is at the point h comma k. Notice you change the sign here, but you keep the sign here. So a, h, and k are going to be given constants. The only variable is really x. So the vertex is at hk. If a is positive, a is greater than 0, then the parabola will open up. You see the parabola opens up, it'll be u-shaped. If a is less than 0, the parabola opens down, it'll look like an upside down u. And in case you're wondering, you say, what about a equals 0? Well, if a equals 0, we don't have a parabola at all. If you put a equals 0 here, that wipes this whole thing out. So the only ones that we're going to get are either positive or negative. So 23, f of x is equal to x minus 1 squared plus 2. This looks exactly like this. You say, where's the a? Well, the a can be understood to be 1. So since a is 1, it's going to open upward. It's going to be u-shaped. The vertex is at 1, 2. Notice we changed the sign here, 1 and 2. Then the axis of symmetry, or just axis, is x equals 1. That's going to be a vertical line. For these sets of problems, all of our axis of symmetry will be vertical lines. X is equal to 1. You just basically just copy the x that's here. And x equals 1, you might recall, is a vertical line. Y equals a constant turns out to be a horizontal line. That was the Yahoo shortcut memory trick that I gave you. So it's going to open up. Problem 27, f of x is equal to negative 0.5. That negative tells me right away that it's going to open down. X minus 7.5 squared plus 8.5. So the vertex is at 7.5 comma 8.5. Again, notice for the vertex, you change the sign here, but you keep the sign. Okay. And the axis of symmetry, or the axis, is x equals 7.5, which is right here. And we already know that it opens down. The parabola opens down. Okay, so now what's so good about having this vertex? The vertex will give you either the lowest point or the highest point of a parabola. So later on, we might want to maximize or minimize a quantity. We're going to be looking for the vertex. So if the parabola opens up, the vertex gives you the lowest point. And if the parabola happens to open down, then the vertex gives you the highest point. It's the turning point where the graph starts to turn the other direction. All right, so for this one, f of x equals x minus 3 squared plus 2. The vertex is at 3, 2. Again, change the sign, but keep the sign. The axis of symmetry, for the axis of symmetry, you simply just let x equal the x coordinate here, x equals 3. All right, so I know the vertex is at 3, 2. There is 3, 2. And then I just pick a point to the left and to the right of 3, namely 2 and 4. So if I plug in 2 to the original, f of 2 is 2 minus 3 is negative 1. Negative 1 squared is 1, and 1 plus 2 is 3. And if you plug in 4, you get the same thing. 4 minus 3 is 1. 1 squared is 1. 1 plus 2 is 3. So I plot at 3, 2, 2 comma 3, and 4 comma 3, and I already know it's U-shaped, so I have the parabola right here. So the vertex is right here, 3 comma 2. It's the lowest point in this particular case. And notice the axis of symmetry is the vertical line x equals 3. So this is the axis of symmetry. You get a mirror image. If you reflect, let's say, this right side across the line x equals 3, you get this picture right over here. So it's an axis of symmetry. It's like a mirror image. This is the mirror image of this. 35, f of x equals negative 2 times x plus 3 squared plus 4. The negative for a, the negative here tells me it's going to open down. So for the vertex, it's negative 3, 4. Again, notice I change this sign, negative 3, but I keep this sign, negative 3, 4. And it opens down. So that tells me the vertex is going to end up being the highest point. It'll be the highest point in the graph if the parabola happens to open down. So negative 3, 4, I plot it, is right over here. Then I pick a point to the left and to the right of negative 3, namely negative 2 and negative 4. So I plug in negative 2 right here. Negative 2 plus 3 is 1. 1 squared is 1. Negative 2 times 1 is 2, plus 4 is 2. Plug in negative 4. Negative 4 plus 3 is negative 1. Negative 1 squared, however, is 1. 1 times negative 2 is negative 2. Negative 2 plus 4 is 2. Right? So I plot the points negative 2, 2, which is right here, and negative 4, 2, which is right here. So I have this point, and this point, so I connected them. I get a parabola which opens down. I already knew that was the case. This is the highest point. The vertex is the highest point in this parabola. The vertex is the lowest point over here. And the axis of symmetry is x equals negative 3. I draw the vertical line, x equals negative 3, and an x as sort of a mirror image. The graph is reflected across x equals negative 3. If you reflect it, pretend there's a mirror here. If you reflect, let's say, the left part, it ends up being on the right part there. 43, in order to get this to look like vertex form, we have to complete the square. It's a variation of completing the square that we did earlier. F of x equals x squared plus 2x minus 3. What you do this time is separate out the negative 3, so x squared plus 2x, leave a space, and then negative 3. Then I do my half and square business that I did before. So half the coefficient of x, half of 2 is 1. That's the half part. Then the square is 1 squared is equal to 1. So back here in red, I add 1, and then I immediately subtract 1. That's different than when we completed the square before, because all of our work is just done on the right-hand side. So if I'm doing it on the right-hand side, if I add 1, I immediately subtract 1, because that means in red, I've essentially added 0. And if you add 0, then you don't change the value of the expression. So I add 1 and subtract 1. That's legitimate. That way, x squared plus 2x plus 1 factors into x plus 1 squared, and this becomes minus 4. So now this does look like in vertex form. So the vertex is negative 1, negative 4. Again, change the sign of this 1, but keep that sign. And that means the axis of symmetry is automatically x equals negative 1. The parabola opens up because the coefficient of x squared is 1. Understood? All right, so I plot the point 1, negative 4. Then I pick a number on this side like 0, and a number on that side which is like negative 2. So I plug in 0. Okay, so 0 plus 1, plugging in here 0 plus 1 squared, that's 1. 1 minus 4 is negative 3. And plug in negative 2. Here, negative 2 plus 1 is negative 1, but negative 1 squared is also 1. And again, I have 1 minus 4, which is negative 3. So 0, negative 3 is here. And negative 2, negative 3 is here. 1, 2, 3, these points, I know it's U-shaped. So I just draw my parabola here. And x equals negative 1. Remember, x equals a constant is a vertical line. And that gives me my axis of symmetry right here. Okay, problem 49. Similar, but a little bit harder. F of x equals negative 4x squared plus 16x minus 10. This time, I have to factor out the negative 4. When I complete the square, you might recall earlier when we completed the square, you wanted the coefficient of x squared to be 1. So I factor out the negative 4 from these two right here. So negative 4 parentheses x squared minus 4x, leave a gap, and then minus 10. If you want to double check, negative 4 times that is negative 4x squared. Negative 4 times negative 4x is 16x. Now I complete the square, do the half and square business. So half of negative 4 is negative 2. Negative 2 squared is 4. So I add 4 here, but in red, if I put the plus 4, because there's a negative 4 in front, I've really subtracted 16, which I'm indicating here. So when I write the symbol plus 4, I'm not really adding 4, I'm really subtracting 16, because negative 4 times 4 is negative 16. So to balance the right-hand side, I will add 16. So again, the right-hand side, I've gone negative 16 plus 16, which is 0. That's a legitimate step. I do get something equivalent to the original. Now I can factor this into negative 4 times x minus 2 squared plus 6. So now this is in my vertex form. And again, I can just read off the vertex, change the sign, keep the sign. So 2 comma 6 is the vertex. The axis of symmetry is x equals 2. And since a was negative, right back up here, the coefficient of x squared is negative, so I know it opens down. So I plot the point 2, 6. My axis of symmetry is x equals 2. And I had x equals 2, so I plug in x is 3 and x is 1. 1 to the left and 1 to the right. So I plug in 3. Negative 4 times 3 minus 2 squared plus 6. Well, 3 minus 2 is 1, and 1 squared is 1. So 1 times negative 4 is negative 4. Negative 4 plus 6 is 2. And if I plug in 1, I get negative 4 times 1 minus 2 squared. 1 minus 2 is negative 1, but when you square it, it's still going to be 1. So it's still negative 4 plus 6, which is 2. So I plot 1, 2, 3, 2, and there's my parabola opening down. axis of symmetry, you can see that this line makes a good mirror to reflect one side on the other. And the vertex is the highest point in this particular case. 59, they only ask for the x and y intercepts. So f of x equals x squared minus 2x minus 35. To find the x-intercepts, we set y equal to 0. Remember, f of x is the same as y, so I replace that with 0. 0 equals x squared minus 2x minus 35. Factor x minus 7, x plus 5. So that gives me x equals 7, or x equals negative 5. So that means the x-intercepts as points are 7, 0, negative 5, 0. Remember, x-intercept and y-intercept are actually points, x comma y. Well, we already know the y is 0, so I write it as 7, 0, and negative 5, 0. Y-intercept means x equals 0, so I plug in 0. Back here it's probably easy. 0 minus 35 is negative 35, so 0 comma negative 35. Okay, then the last set of problems, you're given standard form, f of x equals ax squared plus bx plus c. There's another way to find the vertex rather than going through all this completing the square business. You can just simply go x equals negative b over 2a if your equation is in standard form, ax squared plus bx plus c. Then the vertex happens to occur at x equals negative b over 2a. Side note, you might notice that looks like part of the quadratic formula. The quadratic formula is exactly that, except there's a plus or minus square root stuff. So the vertex is at negative b over 2a. Let's see how we use that over here. F of x is negative x squared plus 6x minus 15. So a is negative 1, b is 6, c is negative 15. The vertex formula is x is negative b over 2a. So negative 6 over 2 times negative 1. That's negative 6 over negative 2, which is 3. Okay, so I know the vertex is at x equals 3. To find the y-coordinate, I just plug in. So plug in 3. So negative 3 squared plus 6 times 3 minus 15, which is negative 9. A quick note, negative 3 squared is not 9. It doesn't mean negative 3 times negative 3. It means the opposite of 3 squared, or the opposite of 9, which is negative 9. So negative 9 plus 18 minus 15 is negative 6. So the vertex is at 3, negative 6. The axis of symmetry is x equals 3. And we know it opens down, which is all that question asks for. And now for a full-fledged graph with an equation in standard form, f of x equals 2x squared minus 8x plus 6. I know it opens up because a is 2. So the vertex is at negative b over 2a. So that's negative 8, which is positive 8, over 2 times a. 2 times 2 is 4, and it gives me 2. And then I want the y-coordinate, so I plug in 2 here, plug in 2 here. 2 times 2 squared minus 8 times 2 plus 6. 2 times 2 times 2 is 8, minus 16 plus 6, which is negative 2. So my vertex is at 2, negative 2, which is down here. The axis of symmetry is x equals 2. And then it asks you to find the intercepts. So x-intercept means y equals 0. So I put 0 right here. Again, you can pretend that's y. So 0 is equal to the right-hand side. 2x squared minus 8x plus 6. Factor out a common factor of 2. X squared minus 4x plus 3. And this factors into x minus 1, x minus 3. So to set that equal to 0, you can ignore the 2. 2 can't equal 0. X minus 1 can equal 0 if x is 1. And x minus 3 is equal to 0 if x is equals 3. So that gives me 1, 0, and 3, 0 as x-intercepts. Then for the y-intercept, plug in x is 0. Plug in 0 here, that's 0. Plug in 0 here, that's 0, plus 6. So it's basically 0 plus 6, which is 6. So 0, comma 6. All right, so I plugged in the vertex is right over here. That's given way back over here, 2, negative 2. I plot down the x and y intercepts. So I have 1, 0, and 3, 0 as x-intercepts. 0, 6 as a y-intercept. I know it opens up, so my general shape is like so. All right, so these are notes for section 8.4, page 725 from Melham's Math 60, Thursday, April the 16th.